Oil reserves are the amount of technically and economically recoverable oil. Reserves may be for a well, for a reservoir, for a field, for a nation, or for the world. Different classifications of reserves are related to their degree of certainty. The total estimated amount of oil in an oil reservoir, including both producible and non-producible oil, is called oil in place. However, because of reservoir characteristics and limitations in petroleum extraction technologies, only a fraction of this oil can be brought to the surface, and it is only this producible fraction that is considered to be reserves. The ratio of reserves to the total amount of oil in a particular reservoir is called the recovery factor. Determining a recovery factor for a given field depends on several features of the operation, including method of oil recovery used and technological developments. Based on data from OPEC at the beginning of 2013, the highest proved oil reserves including non-conventional oil deposits are in Venezuela, Saudi Arabia, Canada, and Iran. Because the geology of the subsurface cannot be examined directly, indirect techniques must be used to estimate the size and recoverability of the resource. While new technologies have increased the accuracy of these techniques, significant uncertainties still remain. In general, most early estimates of the reserves of an oil field are conservative and tend to grow with time. This phenomenon is called reserves growth. Many oil-producing nations do not reveal their reservoir engineering field data and instead provide unaudited claims for their oil reserves. The numbers disclosed by some national governments are suspected of being manipulated for political reasons. Classifications. All reserve estimates involve uncertainty, depending on the amount of reliable geologic and engineering data available and the interpretation of those data. The relative degree of uncertainty can be expressed by dividing reserves into two principal classifications: proven and unproven. Unproven reserves can further be divided into two subcategories: probable and possible to indicate the relative degree of uncertainty about their existence. The most commonly accepted definitions of these are based on those approved by the Society of Petroleum Engineers and the World Petroleum Council in 1997. Proven reserves. Proven reserves are those reserves claimed to have a reasonable certainty of being recoverable under existing economic and political conditions, with existing technology. Industry specialists refer to this as P90. Proven reserves are also known in the industry as 1P. Proven reserves are further subdivided into proven developed, and proven undeveloped. PD reserves are reserves that can be produced with existing wells and perforations, or from additional reservoirs where minimal additional investment is required. PUD reserves require additional capital investment to bring the oil to the surface. Until December 2009, 1P proven reserves were the only type the U.S. Securities and Exchange Commission allowed oil companies to report to investors. Companies listed on U.S. stock exchanges must substantiate their claims, but many governments and national oil companies do not disclose verifying data to support their claims. Since January 2010, the SEC now allows companies to also provide additional optional information declaring 2P and 3P provided the evaluation is verified by qualified third-party consultants, though many companies choose to use 2P and 3P estimates only for internal purposes. Unproven reserves. Unproven reserves are based on geological and/or engineering data similar to that used in estimates of proven reserves, but technical, contractual, or regulatory uncertainties preclude such reserves being classified as proven. Unproven reserves may be used internally by oil companies and government agencies for future planning purposes but are not routinely compiled. They are subclassified as probable and possible. Probable reserves are attributed to known accumulations and claim a 50% confidence level of recovery. Industry specialists refer to them as P50. These reserves are also referred to in the industry as 2P. Possible reserves are attributed to known accumulations that have a less likely chance of being recovered than probable reserves. This term is often used for reserves which are claimed to have at least a 10% certainty of being produced. Reasons for classifying reserves as possible include varying interpretations of geology, reserves not producible at commercial rates, uncertainty due to reserve infill and projected reserves based on future recovery methods. They are referred to in the industry as 3P. Strategic petroleum reserves. Many countries maintain government-controlled oil reserves for both economic and national security reasons. According to the United States Energy Information Administration, approximately 4.1 billion barrels of oil are held in strategic reserves, of which 1.4 billion is government-controlled. These reserves are generally not counted when computing a nation's oil reserves. Resources. A more sophisticated system of evaluating petroleum accumulations was adopted in 2007 by the Society of Petroleum Engineers, World Petroleum Council, American Association of Petroleum Geologists, and Society of Petroleum Evaluation Engineers. It incorporates the 1997 definitions for reserves, but adds categories for contingent resources and prospective resources. Contingent resources are those quantities of petroleum estimated, as of a given date, to be potentially recoverable from known accumulations, but the applied projects are not yet considered mature enough for commercial development due to one or more contingencies. Contingent resources may include, for example, projects for which there are currently no viable markets, or where commercial recovery is dependent on technology under development, or where evaluation of the accumulation is insufficient to clearly assess commerciality. Prospective resources are those quantities of petroleum estimated, as of a given date, to be potentially recoverable from undiscovered accumulations by application of future development projects. Prospective resources have both an associated chance of discovery and a chance of development. The United States Geological Survey uses the terms technically and economically recoverable resources when making its petroleum resource assessments. Technically recoverable resources represent that proportion of assessed in-place petroleum that may be recoverable using current recovery technology, without regard to cost. Economically recoverable resources are technically recoverable petroleum for which the costs of discovery, development, production, and transport, including a return to capital, can be recovered at a given market price. Unconventional resources exist in petroleum accumulations that are pervasive throughout a large area. Examples include extra-heavy oil, oil sand, and oil shale deposits. Unlike conventional resources, in which the petroleum is recovered through wellbores and typically requires minimal processing prior to sale, unconventional resources require specialized extraction technology to produce. For example, steam and/or solvents are used to mobilize bitumen for in-situ recovery. Moreover, the extracted petroleum may require significant processing prior to sale. The total amount of unconventional oil resources in the world considerably exceeds the amount of conventional oil reserves, but are much more difficult and expensive to develop. Estimation techniques. The amount of oil in a subsurface reservoir is called oil in place. Only a fraction of this oil can be recovered from a reservoir. This fraction is called the recovery factor. The portion that can be recovered is considered to be a reserve. The portion that is not recoverable is not included unless and until methods are implemented to produce it. Volumetric method. Volumetric methods attempt to determine the amount of oil in place by using the size of the reservoir as well as the physical properties of its rocks and fluids. Then a recovery factor is assumed, using assumptions from fields with similar characteristics. OIP is multiplied by the recovery factor to arrive at a reserve number. Current recovery factors for oil fields around the world typically range between 10 and 60%. Some are over 80%. The wide variance is due largely to the diversity of fluid and reservoir characteristics for different deposits. The method is most useful early in the life of the reservoir, before significant production has occurred. Materials balance method. The materials balance method for an oil field uses an equation that relates the volume of oil, water and gas that has been produced from a reservoir and the change in reservoir pressure to calculate the remaining oil. It assumes that, as fluids from the reservoir are produced, there will be a change in the reservoir pressure that depends on the remaining volume of oil and gas. The method requires extensive pressure volume temperature analysis and an accurate pressure history of the field. It requires some production to occur, unless reliable pressure history can be used from a field with similar rock and fluid characteristics. Production decline curve method. The decline curve method uses production data to fit a decline curve and estimate future oil production. The three most common forms of decline curves are exponential, hyperbolic, and harmonic. It is assumed that the production will decline on a reasonably smooth curve, and so allowances must be made for wells shut in and production restrictions. The curve can be expressed mathematically or plotted on a graph to estimate future production. It has the advantage of including all reservoir characteristics. It requires a sufficient history to establish a statistically significant trend, ideally when production is not curtailed by regulatory or other artificial conditions. Reserves growth. Experience shows that initial estimates of the size of newly discovered oil fields are usually too low. As years pass, successive estimates of the ultimate recovery of fields tend to increase. The term reserve growth refers to the typical increases in estimated ultimate recovery that occur as oil fields are developed and produced. Estimated reserves by country. BBL equals barrel of oil. Meanwhile, it is estimated that between 100 and 135 billion tons of the world's oil reserves have been used between 1850 and the present. OPEC countries. There are doubts about the reliability of official open reserves estimates, which are not provided with any form of verification that meet external reporting standards. Since a system of country production quotas was introduced in the 1980s, partly based on reserves levels, there have been dramatic increases in reported reserves among OPEC producers. In 1983, Kuwait increased its proven reserves from 67 a GBBL to 92 a GBBL. In 1985 86, the UAE almost tripled its reserves from 33 a GBBL to 97 a GBBL. Saudi Arabia raised its reported reserve number in 1988 by 50%. In 2001 02, Iran raised its proven reserves by some 30% to 130 a GBBL, which advanced it to second place in reserves and ahead of Iraq. Iran denied accusations of a political motive behind the readjustment, attributing the increase instead to a combination of new discoveries and improved recovery. No details were offered of how any of the upgrades were arrived at. The following table illustrates these rises. The sudden revisions in OPEC reserves, totaling nearly 300 BN barrels, have been much debated. Some of it is defended partly by the shift in ownership of reserves away from international oil companies, some of whom were obliged to report reserves under conservative U.S. Securities and Exchange Commission rules. The most prominent explanation of the revisions is prompted by a change in OPEC rules which set production quotas on reserves. In any event, the revisions in official data had little to do with the actual discovery of new reserves. Total reserves in many OPEC countries hardly changed in the 1990s. Official reserves in Kuwait, for example, were unchanged at 96.5 a GBBL from 1991 to 2002, even though the country produced more than 8 a GBBL and did not make any important new discoveries during that period. The case of Saudi Arabia is also striking, with proven reserves estimated at between 260 and 264 billion barrels in the past 18 years, a variation of less than 2%, while extracting approximately 60 billion barrels during this period. Saadad Al-Husseini, former head of exploration and production at Saudi Aramco, estimates 300 a GBBL of the world's 1,200 a GBBL of proven reserves should be recategorized as speculative resources, though he did not specify which countries had inflated their reserves. Dr. Ali Samsam Bakhtiari, a former senior expert of the National Iranian Oil Company, has estimated that Iran, Iraq, Kuwait, Saudi Arabia and the United Arab Emirates have overstated reserves by a combined 320 a 390 BN barrels and has said, as for Iran, the usually accepted official 132 billion barrels is almost 100 billion over any realistic assay. Petroleum Intelligence Weekly reported that official confidential Kuwaiti documents estimate reserves of Kuwait were only 48 billion barrels, of which half were proven and half were possible. The combined value of proven and possible is half of the official public estimate of proven reserves. In July 2011, OPEC's annual statistical review showed Venezuela's reserves to be larger than Saudi Arabia's. Prospective Resources, Arctic Prospective Resources. A 2008 United States Geological Survey estimates that areas north of the Arctic Circle have 90 billion barrels of undiscovered, technically recoverable oil and 44 billion barrels of natural gas liquids in 25 geologically defined areas thought to have potential for petroleum. This represented 13% of the expected undiscovered oil in the world. Of the estimated totals, more than half of the undiscovered oil resources were estimated to occur in just three geologic provinces: Euro-Arctic Alaska, the Amurasia Basin, and the East Greenland Rift Basins. More than 70% of the mean undiscovered oil resources was estimated to occur in five provinces: Arctic Alaska, Amurasia Basin, East Greenland Rift Basins, East Barents Basins, and West Greenland or Euro-East Canada. It was further estimated that approximately 84% of the oil and gas would occur offshore. The USGS did not consider economic factors such as the effects of permanent sea ice or oceanic water depth in its assessment of undiscovered oil and gas resources. This assessment was lower than a 2000 survey, which had included land south of the Arctic Circle. Unconventional prospective resources. In October 2009, the USGS updated the Orinoco tar sands value to 513 billion barrels. In June 2013, the U.S. Energy Information Administration published a global inventory of estimated recoverable tight oil and tight gas resources in shale formations, technically recoverable shale oil and shale gas resources, an assessment of 137 shale formations in 41 countries outside the United States. The inventory is incomplete due to exclusion of tight oil and gas from sources other than shales such as sandstone or carbonates, formations underlying the large oil fields located in the Middle East and the Caspian region, offshore formations, or about which there is little information. Estimated technically recoverable shale oil resources total 335 to 345 billion barrels. See also: Decline curve analysis, Global Strategic Petroleum Reserves, Oil Exploration, Peak Oil, Petroleum Industry, Strategic Petroleum Reserve, Energy and Resources, Petroaggression, Energy Security, World Energy Resources and Consumption, List of countries by natural gas proven reserves, references. External links: OPEC Annual Statistical Bulletin, Energy Supply page on the Global Education Project website, including many charts and graphs on the world's energy supply and use, oil reserves by country, Statistical Review of World Energy BP Statistical Review of Energy 2013.